In this video, I'm going to show you how you could create histogram plots using Matplotlib in Python, and we're starting right now. So the links to this Jupyter notebook will be provided in the video description. And let's start by generating the data. So here we're going to be importing NumPy as NP, and then we're going to be setting the seed number to be 100 in order to allow reproducibility of the following dataset generation here. So here we're going to generate random numbers in the range of 0 to 100 with a standard deviation of 10. And then we're going to assign this randomly generated numbers as an array into the x variable. And let's run it. So you can see here that this is an array or a list of values. And we're going to be using these values for making the histogram. And so here we're going to import the library. So we're going to import matplotlib.pyplot as plt. And in order to create the histogram plot using matplotlib, hist function. And so the hist function is accessible by typing in plt.hist and then input argument of x, because x is the data that we're going to be creating the histogram for. And then we're going to use plt.show function in order to display the plot. Let's do that. And here we get a beautiful histogram using the default parameters, meaning that all other options are set at default. So the only input argument that we need in order to make the hist function work is the input data, which is the x variable, which we have generated a couple of seconds ago. And let's say that if we want to customize the features of the plot, what can we do? Let's take a look at that. For example, if I would like to modify the color, I could change the color by specifying it directly to the color option. And so in addition to specifying the data, we could do color equal and then green, or color equal to sky blue. For example, you can see here that the default color is blue. Let's make it green. And here it is. Let's make it into a sky blue. There you go. And so you could specify the color that you want in here. And so here you can see at default that the bin size is set at default to be 10, meaning that there are 10 bars. Let's run again. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then each bar will represent a range of values. The range of value from here until here. So this is about minus 25 until minus 20. How many do we have? We have 1. In the range of minus 20 to minus 15. How many do we have? We have 7. And then the third bar is the same. From minus 15 until minus 10. How many do we have? We have 8. And so each bar will represent the occurrence of values falling within the range specified underneath the bar. So each bar is also known as a bin, and at default it is set at 10. Let's say that we want to modify the number of bins to be 5. We could use the bins option here equal to 5. And then you're going to notice here that we have a total of 5 bins. And now the range is modified from minus 25 until minus 15. Minus 15 until minus 5. And so the range of the bar increases to 10. Whereas in the prior plot, you can see that the range of the bar is 5. From minus 25 until minus 20, which is 5. Okay, and so you can see here that at default, you do not see any title, you do not see any x-axis label or y-axis label. Let's say that if we want to add them, what can we do? We could do the following. We could create two variables here, fig and ax, equal to plt.subplots function. And then we will set the ax.hist function with the input argument of x, which is the data that we want to use for the plot making. So here we could use the setTitle function in order to specify the title of the plot. And we're going to call it histogram plot. And then we're going to set the x label here, set x label. And we're going to call it x-axis label. And then we're going to use the setYLabel function. And then we're going to call it y-axis label. And notice that we all use ax in front because we have already specified it to represent plt.subplots. And then finally, we will end it with a plt.show in order to display the plot. Now let's run it. And now we have the title of the histogram, we have the x-axis label, we have also the y-axis label. What else can we do with the histogram? Well, we could change the style of the plot. Let me show you what available styles do we have. So we're going to use the plt.style.available. And here we print a list of the available style options that we have. And so here we're going to create a for loop in order to iterate through all of these available styles. And then we're going to create a plot of each of the style so that you can see how each of them look like. Let's run it. So in the for loop, it will be iterating through each of this member in the list one by one. And then for each iteration, it will start by printing out the name of the style. So here it starts from solarized light 2. And so it's going to use the print function right here. It will print it out, and then it will use the style to be solarized light 2. And then it will make the histogram and show it, and then iterate through the next one. And then iterate through the next one, and then until it has iterated through all of them. Okay, so each of these are the available output style that you could make. And notice here that this resembles the ggplot from R. And this is resembling the one from 538 website, which is a popular data storytelling website. And also, it could also mimic Seaborn as well, and various flavors of Seaborn, as you will see here. And let's say that in a practical situation, we're not going to iterate through all of them. Let's say that we want to use ggplot, and so we could just specify plt.style.use and then specify ggplot as a string. And then we will use the plt.hist function and then specifying the data to be x, and then plt.show in order to show the histogram. And here we go. Let's say that we want to modify the width of the bars. What can we do? Well, we could modify the values assigned by our width option here. And it could take a value from 0 to 1, where 1 meaning it has the full width. And 0.1 will be the small one. And here we're going to use 0.1. Let's give it a try. Because any thinner will make it very difficult to see. And let's try 0.5. And let's try 0.9. Notice here that when it's 0.9, we have a bit of a spacing in between, which might allow us to differentiate each of the bar easier. And then the next one is to adjust the orientation of the plot, because at default, it is using the vertical option. And here, we're going to try to set it to be horizontal. Let's have a look at the default, which is vertical. And let's set it to horizontal. There you go, it looks like that. But when it's horizontal, we might need to adjust the figure width, the width and the height of the figure. I'll show you that in just a second. So you want to stick until the end of the video to see how. And here we're going to adjust the type of the histogram bar. So at default, we're using the bar option here. But then we're going to try the step. Let's run it. Notice anything different? Well, you guessed it, we only see the outline here of the histogram, and so the fill is not shown here. So if we use the step filled, it will just look like the one we have shown above. It'll look like the bar option because it is showing the fill. Now let's say that we want to adjust the color of the edge of the bar, and we could do that by using the EC input arguments and set it to be the color of our choice. Let's try it to be black color. And here you go, it looks really nice. It allows us to differentiate each of the bar a bit better. Let's continue. Here we go. Here we could adjust the figure size. So in order to do that, we're going to use plt.figure function, and then as input argument, we're going to use the fig size equal, and then we're going to set it to be 10 and 5. Let's have a look. Now let's adjust it to be 5 and 10. Let's reverse. Let's have a look again. There you go. So remember that we changed the orientation just a moment ago here. Let's add it here. And then it looks like this. Okay. Let's change it back. And then finally, we're going to save the plot that we have generated into a PNG format or also into a PDF format. So in order to do that, we need to generate the plot first by using plt.hist and then x as the input argument. And then we use the savefig function here and then specifying the name of the file, plot.png. And in order to save it as a PDF file, we simply change the file name to plot.pdf using the savefig function. And then if we look to the folder icon to the left panel here, these are the generated files for PNG and PDF. Let's double click on PNG. And here we go. Let's download it. And let's compare the PDF and the PNG. This is the PDF and this is the PNG. So seemingly it looks quite similar. But what if you zoom in? You notice that, the bar is not breaking up, but then the numbers is a bit pixelated. But if we do the same for the PDF version, it's crystal clear because it is a vector, whereas the PNG is a raster, so it becomes pixelated. So normally I like to use the PDF version for my reports and also for my publications. Okay, and so there you go, a complete video on how you could create histogram plots using Matplotlib in Python. And also check out these free resources that I have created for you to learn Python and R for free on this YouTube channel, The Coding Professor. And also, if you're into learning data science, then you want to check out my other channel, Data Professor. And also, I write media blog posts teaching data science, and so you want to check that out. And I share all of the code and data on the GitHub. And also, I share my best tips and updates in data science, and also occasionally providing freebies from data companies in the industry. And also connect with me on Twitter, LinkedIn, Facebook, and Instagram. Or if you're feeling like it, you could also buy me a coffee. And so if you're finding value in this video, please help the channel out by smashing the like button, subscribing if you haven't already, and also hit on the notification bell so that you will be notified of the next video. And until next time, happy coding!